Hello there, welcome to Blockchain Nuts and Bolts. This video will be focusing on IPFS CLI commands. So while the other two videos that I had posted focused on installation part and initiating part and running the daemon part and adding few sample files. Now this video will be focusing on the commands, IPFS commands in all together. So while I'll not be covering all the commands since they are in hundreds, but I'll be covering most of the major commands that we'll be using in our routine interaction with the IPFS CLI terminal. So let's start. So we will start from the terminal, from the same terminal that we had installed in the earlier video. So we have got this terminal and IPFS is already installed, so it's ready to go. So what we'll do is, first of all, IPFS commands. So this is one of the first commands that I'll be covering, and all the commands that I'll be covering, they are not in any particular sequence. Whatever comes to my mind, I'll just keep doing them, executing them, and then at the end of it I'll also compile them, try to compile them all, and I'll share the link in the description so that you have that ready reference. So IPFS commands, what are the number of commands? So we'll just say IPFS commands and it shows here. So these are the number of commands. So we'll just see if it gives out how many commands are there. So there are about 181 commands which are listed here. So of these 181, I intend to cover about 40-50 of them majorly. So now till now I have not started the daemon, so I'll just start the daemon part also, and we see it here. Okay, before while it is running, I'll just show you the web interface. So whatever terminal commands we are giving out here, so there is another way that we'll be able to access our node, and that's this 127 dot, okay, I have it here, webui. So this is basically giving the web interface. So while it populates over a period of few minutes, I think, so it will take some time. So this happens and this runs only and only when this daemon is running. So while this daemon is ready now, so it will populate and we'll get back to that in few minutes. So now we have the daemon running. IPFS. Okay, now suppose I have this IPFS command. So in case I just type --help, so what I'll be getting is just like man. So like in Linux terminal we use the man command, man, and we give out the command name, so we get the complete details of usage, synopsis, options. So similarly here, so in case of using any command, IPFS command, in case we just append it with a --help, we get to know what is the command like. So IPFS commands, it lists all the available commands, and there are few suches that you are seeing on the screen. So next is, now IPFS has a default configuration. So how to see that, what is the default configuration? So IPFS config show. So this is the default configuration, and we'll not get into all this of what exactly each line means, but these are the default parameters which have been set. Now while we have accessed this file with this command IPFS config show, there is another way that we can simply go to the directory cd IPFS, and we'll see, and we'll just more config. This is the config file that we had accessed through the command, and this is the way that we are accessing it directly. So this is the same content, but we are accessing it directly, not through the command. Then in case we want to see the version, what version I am using, so IPFS -- version, we get the version. So it is 0.1. It shows basically the information about the dependencies that on this IPFS has been built on, and what am I using. Then there is another interesting command is IPFS ID. Now IPFS ID, when I say the hash after the peer identity is the node, is your node's identity. So for example here my node identity is 123. So among all the IPFS peers that are running, that are on the network, this is my unique ID. So I will be identified on the IPFS node with this ID, and this is supposed to be different in your case. In case you are doing it on your own terminal, so this is this IPFS ID what you see here, this is going to be different. So other nodes on the network use it to find and connect to me. So if I share my ID with them, so they'll be able to connect with me, they'll be able to add me to their PS or reliable ID. So you can run IPFS ID at any point of time to get it again if you need it. So in the middle of it, this can be run anytime. So now we come to adding files. How do we add files? So we'll just create a directory BNAB, and we'll go inside it BNAB, and we'll create a file, and we'll say echo blockchain nuts bolts, and we'll say it is known as BNAB, and we'll create another file blockchain nuts and bolts 1, and we'll name it BNAB1, and we'll take another one 2, and we'll place it 2. And now we'll do one thing. We will just rename this. We'll make one of these files. So currently the listing is currently the listing is BNAB, BNAB1, BNAB2, and now among of these 3 files I'll just make BNAB2, BNAB2. I'll make it hidden. So why am I making it hidden? I'll just let you know. So we have got 2 files visible, and in case I list the hidden files, so I'll be getting 3 files. So there are 3 files, and in case I just want to know what is the content inside, just verifying. So these are the blockchain nuts and bolts, block 1 and 2. So we'll clear the screen. Now why am I doing this? So first of all, inside the directory I will just say IPFS add BNAB. That's it. So that's the simple command wherein we can add files. So while I have added it here, I have got a output which is here, as you see on the screen. This is the output. Now this is the IPFS hash of this particular file BNAB, and this is unique to this. And there is and as I had told you in the introductory video, anything starting with QM is a version 0 file. And how to convert it into V1, we'll see it later in the video. So while this hash has come, so we can also play with this IPFS cat. Okay, IPFS cat, and in case I simply put the hash here, so instead of reading the file, so we are just playing with the thing, what the hashes we have created. So we are simply able to cat the file, simply able to read the file from the IPFS terminal, IPFS cat, and you give out the hash, you will be able to read what you have uploaded here. So now now I'll come out of this directory. So now I come out of the directory, and what I do is I'll just list ls-lrth. There is this directory. Now I'll add this complete directory to the IPFS thing, IPFS, and the command is IPFS add -r recursive BNAB. That's all. So here I have, if you see, there are I have got 3 files inside this BNAB. So BNAB1, BNAB2, and BNAB3 was hidden. So here, while I have used this command IPFS add -r BNAB, what has happened is I have got a hash for BNAB, I have got a hash for BNAB1, but not for .bnab, the hidden file. And there is another hash that we are seeing here, BNAB. Now this is the traversing hash. Now I'll show you what traversing hash means. So meanwhile, first of all I'll show you how to add the hidden files. So in case we want to add the hidden files, so IPFS, the command is IPFS add -r -H and then BNAB. So this will add the hidden files also. Now, so this is the hidden file B1, and we are seeing it here. So now, and these are the same hashes. GXEC, BI2, BI2, but in addition we have got this hidden file also this time, b.bnab. So to add the hidden files, you simply have to add a switch -h. So this h is added, and we have got the hidden files. Now there are ways and means so that we can just alter the output. So while I have done this, so I got this output. Now in case I want a little quiet way, I can simply add -q, So I am here while showing you, I am removing this H switch, the capital H switch. So I am only considering the normal files. So if I say IPFS add -r -q, so my small -q is quiet. So this will give me a quiet output. Now what is quiet output? There is no other information which is giving out. So the q, small q, means simply the hashes will be generated. It will not show from where it is, what file it means and what files it represents. So it is simply showing me the hashes. So instead of small q, if I write capital Q, so this is basically known as quieter. So that was quiet and this is quieter. So quiet only writes the final hash. So this will give me only one single hash. So this is the final hash, the root hash, the Merkle hash maybe. So this is the final hash which is coming out. So these are just switches that I'm mentioning out here. Okay, now let's come to if we what's the meaning of that traversing thing that I was telling you. So we can add so we have this directory and we have already added these files. So we'll come out here again and IPFS add -r. Now I'm just repeating that command so that I'll show you what does it mean actually. So now if I have to access this file, this, so I'll say IPFS cat, I'll place this here and I can simply say BNAB1. So it will give me the output. So this is the traversing thing that we have derived here. Similarly, if I say IPFS cat, if I take this hash and then place it here and then I say BNAB, so this will give me just blockchain nuts and bolts. Oh, did I do something wrong? IPFS cat QM BNAB, okay, /BNAB. Sorry. So what am I doing here? What wrong I am doing here is that I am placing this direct hash here and I am traversing. I am not doing the traversing thing. So what I am doing wrong here is I have to place this the root hash here and then type BNAB. So this will give me blockchain nuts and bolts. Now coming inside CD BNAB, we come inside the directory and we simply add IPFS add BNAB. So if I add a switch here, IPFS add -w, so this small switch, this is this W is basically means the wrap option, though it wraps the file. So now instead of getting one hash, we'll get two hashes. So one hash represents the BNAB, this is the same, this is the same, and this additional hash that we are getting, this is kind of a traversing thing. So this directory contains only the files which have been added, means the file retains its file name. So here what exactly I'll show you. So it is exactly like IPFS cat, so I'll place it here and I say BNAB and blockchain nuts and bolts. So we are reading a traversed form. So while so -w, what it adds is it wraps up, so it gives a additional hash wide, which in now here we have got just I am accessing just one file or maybe two files. So in case I want to read through the hash, the root hash, I'll be able to read it this way. So now we'll clear the screen. Okay, another thing that I forgot is, so this is the other hash. So in case I want to read it later, IPFS ls, so what does it mean? So it will give me some listing. So what have I done is IPFS ls is list command, and here I am mentioning this root hash. So this will list that inside this hash there is this particular hash which is representing BNAB. So it is simply listing it. And you can also do ls -v simple output difference, that hash, this is the hash, and you see what is the difference coming like. So minus v is just giving some additional details. Now we'll clear the screen. Now we come to a command known as IPFS swarm PS. So IPFS swarm PS, now it has listed out so many things, and these are bound to be different in your case in case you do it at your own terminal. So these are a combination of the transport addresses P2P and the hash of public keys that is peculiar to my node. And in case I just want to see the swarm addresses, so it will give me the swarm addresses. So these are all the swarm addresses. Now if you want to know what exactly all these pairs are, so minus help, and it shows me what IPFS swarm pairs means like. So IPFS swarm pairs, it says it lists the pairs with open connections. And similarly, in case I do for this, so IPFS swarm address, it lists the known addresses useful for basically debugging. So we'll get back to other commands. So there is another command, IPFS swarm address listen. So this lists all the interface addresses the node is listening on, and this is again will be peculiar to me. You might have something different, and then I can also say instead of listen, what are the swarm addresses local to me. So this will list all the local listening addresses announced to the network. So now after this we come to another command which is known as the chunker option. Now what chunker option is? Chunker is basically it is switched. The switch is known as -s. Now chunker option, it specifies the chunking strategy that dictates how to break the files into blocks. Now if you remember, if you have seen the earlier video wherein I had shown that a typical file, while it is uploaded to the IPFS protocol, it is broken into a number of pieces. Now all those pieces, what is going to be the size, how many times it is going to be duplicated around, and all those parameters which are basically populated in the config files, so we can customize them. So I'm just giving you an example here. So IPFS, these now different chunking strategies will produce different hashes. So in case I have a different chunk strategy other than the default, which is by default in the IPFS, so my hashes will be different for the same file, because of obviously if the chunks are different, the hashes will be different, and in case the hashes are different, then the root hash is bound to be different. So the default in the IPFS, it is a fixed block size of 256 into 1024, that is about 262.144. So alternatively, there are other protocols, other algos like buzz hash or Rabin fingerprint that I'll just show you. Now before I do and show you an example, I'll just download a file here, a video file basically. So this video file I'm downloading because I intend also to show you later of how to play it. So this is it, this is the file. I'll just download it. So wget, and it is known as 640, and it is downloaded. So we'll come back to the host machine, and we are here. So it should be listed ls. So this is 640 MP4 we have downloaded. Now we are planning to use the chunker option. So IPFS add -- chunker is equal to size. Now I am defining the size 2048, and I say 640.mp4. So I'll just clear the screen. IPFS add -- chunker is equal to size that I have defined here, 640.mp4. Now it has given me this particular hash QMTV. Now in case I had not used all this chunker option and I had simply used add 640.mp4, so it has given me a different hash, because here I have used a custom division of the block, custom division of the file, basically customizing my chunk size, and here it is the default. So this is peculiar to what custom size I have given, and this is the default thing that I have given. So in case I use another option, instead of the thing chunker defining my size. So I can also use chu chunker is equal to, this is rebin minus 512. Herein I will be defining different sizes 512, 1024 to 2048, and I'll execute this command. So this is the command IPFS add minus chunker is equal to rebin dash 512 dash 1024, and we run this file. So now this is a different hash that I have got here. So this is G and Z. So in case I go here, so these are all the different hash. Now again, what do we do from here while we have got this and we have stored this somewhere? So how do I connect it later? IPFS object links, and I list this hash here. So what does it give me? All the size, all the chunks, all the files which have been created, all the blocks which have been created. So these are all in different sizes, and they basically define as per this range 5 and 2. Now in case I go to the earlier command again, this one 5, and in case I say object links and I mention this instead of the rebin val, so here you see all these file sizes chunks are same except for the last one, because it is the last one, and so these are all the same sizes, while I had shown, while in the rebin the sizes were different, their range was given. We'll close this. So now we come to another thing which is known as pinning. Now pinning is a very important concept in IPFS, and IPFS semantics try to make it feel like every single object is local. So while you access a IPFS file which is actually not stored on your PC, but it is being fetched from different nodes, so this pinning makes it feel local. So there is no kind of retrieve this file for me from a remote server. You have to just do IPFS cat or IPFS get. So let's see what is currently, how do we use this IPFS pin ls. So these are all the things that we are seeing here. Now interesting thing is what you see here, while I have listed this IPFS pin ls, so there are a number of hashes which are seen here. Along this side you see sometimes at some places it is written indirect, at some places it is written recursive, and at some places you might even see something known as direct, so which is currently not there. So that we can just see. So what does this direct, recursive and indirect mean? So direct basically means direct pins which pin just a single block and no others in relation to it. So basically they just pin a single block. Recursive means they pin a given block and all its children, all its subsets, all its subdivisions, basically the complete leaf, complete root. And majorly what we had seen here, these are all indirect. So indirect, these are the results of a given block's parent bin being pinned recursive. So we'll just see what does it give. So we'll go to the directory cd BNAB. This is just for testing purpose that I had made in the beginning. So if we say IPFS add BNAB, so what does it give? So this we had already seen. Now we'll just see, we'll say IPFS pin ls and grep, and we'll say this hash here. So this will give me the listing with the identity mark, whether it is direct or recursive or something else. So here it says that this hash what I have listed out here, this is recursive in nature, recursive in. So in case I just want to list out IPFS how many recursive and how many direct, minus type is equal to recursive, and then simply count it. Some mistake I have done. Okay, sorry. So there has to be a space here. So there are 40 files which are recursive in nature. In case I want to know how many are direct, you might see 0, 0, in case I say indirect, how many are there? So there are about 7,291 files currently. Now these three files, the direct, recursive, indirect, they can also be changed and removed as per our things. Now, so now this file that we had just seen, IPFS, this one. So this is recursive. So in case I want to remove this, so it is simple IPFS pin rm, and we'll say here. So it is, we are removing it. We have removed this. So now this is unpinned. This is just an example. Now if I run that same command again, while I had, for this command, I had got this output. This hash is recursive. Now I am running the same command after removing it. So now it is indirect. It is indirect. It is not, it is no more local to me. So now we come to the next command, which is known as garbage collection. So garbage collection, I'll just show you cd. We'll come out of this directory. We'll go to the cd.ipfs, and here I'll just show you this file again, more config, and we'll. So here you see all the parameters, and in all these parameters I am trying to show you something known as the garbage collection storage max value. So yeah, so storage GC, this is the storage garbage collection watermark. This is 90 and storage max is 10 GB. So these are the default sizes that are given here. So what is GC period? What is seen here? So here, while we discuss about the GC period, so GC period means it the parameter defines how frequently this garbage collection should run if automatic garbage collection is enabled. So the default is set to 1 hour. Default is set to 1 hour, and we can change it. Now storage GC watermark, this 90, what this 90 means. So this defines the percentage of the storage max value that will trigger the automatic garbage collection as long as the daemon is running with automatic garbage collection enabled. So this default value, even if you see your config file, this is going to be 90 only. So IPFS repo is used to manipulate the this thing. So we'll just come out of this. So IPFS repo GC. Now what does this command means? It performs a garbage collection sweep on the repo. Garbage collection sweep on the repo. So okay, before running I'll just say help. So it performs a garbage collection sweep on the repo, and it is a plumbing command that will sweep the local set of stored objects and remove ones that are not pinned in order to reclaim some hard disk space. So we'll now, without minus help, we'll just run this, and we see all these files are removed. So these are all removed. So in case I do again the same command, so it is empty. Now I say IPFS repo stat. What is the stat? So stat, it basically gets the stats for the current used repo. So these are the basically stats which have come up. And in case I say IPFS repo verify, so it verifies all the blocks in the repo which are not corrupted. So all the verification is complete and all blocks have been validated. Yeah. Now IPFS, another command is IPFS repo version. So basically shows the repo version, and this is that FS repo 11. So it is like IPFS minus version. So it was 0.11 and this is FS repo 11. So next command that we see here is IPFS bitswap. Now bitswap basically gives the diagnostic information. IPFS bitswap stat. So it is basically giving the information of bitswaps here, and we can just run a help command here. So what exactly it means? It shows some diagnostic information on the bitswap agent, and -v, it prints some extra information, minus human. Okay, we'll just say -v. So we have got this extra information, we do not want this, and other was human. So we'll say human, and let's see what it prints sizes in human readable format. So okay, So instead of those bits and bytes, we are getting in a more relatively easy to read manner. So these are all that's all the difference that it makes. There is another command again related to bitswap, IPFS bitswap want list. So first of all, I show you the help minus it shows blocks currently on the want list. So what are the blocks on the want list? Currently they are 0. Okay, then there is another command for which I will have to get the ID. So what is my IPFS ID? It is this is the ID. I'm just copying it because I want it for the next command, IPFS bit swap ledger, and I paste the thing here. So this is again giving some kind of other information. Now since I have removed most of the garbage collection values and other things, so it is coming as 0 currently. So now we go to the next command. So we go to this directory again, cd BNAB, and now we have got this IPFS block command put BNAB. So it is put. So this is basically just it is storing this BNAB as a IPFS block, not as a IPFS file. It is just getting it stored as a IPFS block. So in case, now there is a difference. If I say IPFS add BNAB, this is going to be different hash. So while it is QMD FR XLE, here it is different. So this was stored as a IPFS hash. Now here when I have done this IPFS block put, so this is being stored as a block. So the thing is, we'll just copy it and I'll show you IPFS block, IPFS block get, and I place this here. So I am able to directly read the file from a block. Now if I say IPFS block, same command, but instead of get, if I say stat, so it is giving me the size of that file. And in case I want to remove this IPFS block rm, and I say here the same hash, so it is removed. So now if I say block stat, so ideally it should not be listed, so it is going into a blank mode. So I'll control C it and come out of it. So then next command we come on to is the bootstrap command. So what bootstrap means is IPFS bootstrap list is a list of peers with which the IPFS daemon learns about other peers on the network. So while we just list out bootstrap, so IPFS comes with a default list of trusted peers. So this you don't have to do it yourself, or you don't have to populate it yourself. This comes with a default list of trusted peers, but also at the same time you are free to modify the list to suit your needs. So in case you are not comfortable with the default list of peers which is given by the in an automated manner while you install IPFS, so you can have your own trusted peers. Now we'll just run out few commands of the IPFS bootstrap list. So we'll say IPFS bootstrap list. If we say bootstrap list, it gives me this. If I just say IPFS bootstrap, even then the list is going to be the same, the output is going to be the same. If I say IPFS bootstrap add default, so it is just adding the default things. So it is just adding the same things again. So this is the way that you add something to your bootstrap list. So if you want to remove all these default list of peers which were shown here, so I will just IPFS bootstrap rm minus minus all. So these have been removed, but you want now it is empty IPFS bootstrap list, but you need to add something. So we have added them back. So now if you list them, so again you will be seeing the list again. So this is basically, you want to play around with bootstrap list, but just be cautious that whenever you add your any peers and you remove all this, so you have to be very cautious, because the moment you add any malicious peer, so it might have some security repercussions. So we'll go back to the terminal and see some new commands. So the other thing which is coming up now is IPFS CID bases. Now all the available multi-base encodings, so this is all what IPFS supports. So this is basically listing out the available multi-base encodings, -- help. So list available multi-base encodings, and that's it. So so base 32 is what is the default, I think. So we'll, and then apart from CID bases, we have the codecs. Again codecs, these are the lists, git raw, etc. So it is basically listing the available CID codecs which are supported by IPFS. Then we can say CID hashes, what all hashes it supports, and there are a number of them. So how many of them? WC -L. So there are about 72 types of hashes which are supported. So if I'll just give out a command, IPFS add --CID version this is if I am peculiar about some particular hash. So hash, if I say Blake 2B 256 -NQ and I say BNAB, so there's something wrong that I have done. IPFS add --CID -version 1. Okay, I have to place 1 here, I forgot here. So what has happened is that I have, instead of getting a version 0 output, I have used this hash and I am directly getting the output address output as version 1. So this is the version 1 equivalent of BNAB if I use a Blake 2B 256 hash. So now we will move ahead. So there is another command which is known as IPFS DAG, IPFS DAG, and it is used for creating and manipulating DAG objects and hierarchies. So we'll use, okay, IPFS add BNAB, and if I see the IPFS DAG stat, and if I try to read it here, what does it give me? So it says the size is 30 and the number of blocks is 1. So then another thing is IPFS diag. So this command basically generates the diagnostic reports. So this must have generated, I think. No. Okay. So the next command is IPFS diag. So this is basically meant for generating the diagnostic reports. So generates the diagnostic reports and lists out. Okay, we'll just run all these. CMDS, so list command run on this IPFS. All these commands have been run. Then diag profile, so collects a performance profile for debugging. So it is likely to take few seconds or maybe a minute before it generates a zip file which will be the profile file. So this IPFS diag profile, it collects a performance profile for the basically used in debugging, and it collects the CPU heap and go routine profile from a running go IPFS daemon, that is into a single zip file. So now it has written this into a single zip file which we see on the screen here. So this is the zip file which has been created, and this basically helps in debugging, and we'll move further. So IPFS diag sys, so this basically prints the system diagnostic information. So this will be useful for debugging at any point of time, prints out the information about the computer to aid in easier debugging. And then IPFS, then we have got IPFS, diag, cmds, clear. So whatever commands peculiar to the diagnostics we have done, we can just say clear inactive request from the log. So it is cleared. Now if I say IPFS diag command, it is going to list only few of them, the default ones. So now we'll go ahead and I say IPFS key. So this is basically meant for creating and listing the IPNS key pairs. So IPFS key currently is likely to be IPFS key -- help. So the next command is IPFS key list. Now there are likely to be two keys that I have created earlier, self and Rajni, and we'll create another one. So IPFS key gen -- type is equal to RSA -- size is equal to 2048, and I name it BNAB. So let BNAB key, let me name it as. So this is a key that I am creating. Okay, sorry, it should be 2048, I mistyped it. So this is a BNAB key. Now what does this mean basically? So we'll just first of all list out. So now instead of 2 there are 3 files. So earlier there were this self and Rajni. Now we have created self, BNAB and Rajni. So what does it do? So for this I'll just come out IPFS add 640. So this is, I'm just repeating the command because I have to use the hash. So this is here, and now I'll say IPFS name publish key is equal to BNAB key, and I put the hash here. And now this key is being published. This key is basically publishing, the message will come that this file has been published with the key, BNAB key. So while earlier it used to be default self or default Rajni, the other keys, now here I am publishing it with BNAB key. So in few seconds it will just come the message published to so and so queue and the traversing address. Yes, so it has taken about a minute and it has finally come that this file, the hash of this file, which is this file, now it says that this has been published to K2KR. Now this is the key of this particular file that I had created, BNAB key, and it is published at this location. So we'll move further, and this BNAB key, that I had created, this can also be renamed IPFS key rename BNAB key, and we can simply write BNAB key 1. So I'm just renaming the keys. So now it is renamed to key, and in case I say IPFS key list, so instead of BNAB key it will be BNAB key 1. So this is all about the key part. So now we move ahead. So next is IPFS stats BW. So it is basically prints the IPFS bandwidth information. So again, the total in, total out, rate in, so bandwidth minus help. So this is all about the description part. IPFS stats BW prints bandwidth information for the IPFS domain, total in, total out. By default overall bandwidth and all protocols are shown. Okay, so this is, we have already run. So this is what it looks like. So while these commands are over, most of the commands that I have shown you here, so now we'll get to that web interface that I had opened at the beginning. So we'll close this, and now how do we access? So we simply write 127.0.0.1 colon 5001 and colon web UI, and here it is. So once you type in this, you get this particular access, and this is supposed to run only when your daemon is running. This will not run if you're just using it without daemon running. So this will not be shown. Now I'm just going to show you what all information it gives out here. So these are the side panel status. So status is this is basically defining what is the incoming and outgoing traffic. How many files have I used? Okay, now whatever files I have done by the command IPFS add. So in case I want to add something here, so I can add in a GUI manner also. So in case I have this file 1.jpg, so this will simply be added, and here the hash is generated. So this is the GUI way of how we can add the files to the IPFS protocol in a GUI manner. Then we have got this explore, Merkle forest, etc. Okay, peers. So these are the swarm peers that we had seen with the IPFS swarm peers command. It is taking some time. So there are about 893 peers. So this is basically bringing out all that same information that we had seen on the terminal, but in a GUI manner. Okay, now I forgot to show you one interesting command, version 0 and version 1. How can we move directly swap between version 0 to version 1? How do we change the addresses from version 0 to version 1? So there is a command line way and there is a GUI way. I'll show you both. So we are already in this directory, and I will IPFS add BNAB. I'm just showing you again. So this is the version 0 format which we have derived. So in case I want to convert it into a address of version 1, IPFS CID format -v, and I change it to version v, and I'll say base 32. I mention it here. So this is going to give me some wrong IPFS CID format -1. Okay, I forgot to place a B here. This is a switch -B. So I have got this address version 1. So I have converted basically this version 0 address to version 1, and in case I want to do it in a GUI manner, I will simply copy it here, and I'll go to another inspector which is known as the CID inspector, cid.ipfs.io. this is the website you are seeing on the screen, and you have to simply paste it here. I have pasted it here and here, and I have got the version 1 equivalent here. So BAFYBEDUEVW. So this is same what we have got here. So these thing and this address and this address. So this we had derived on it in a terminal manner, and this we have derived in a GUI manner. So coming back to the GUI part. So all these settings in the config folder that we had seen, so these all settings can be changed here, and this will need a separate video for now. I think this only the IPFS command peculiar video I would like to just end it here. So till now, just basically a revision kind of a thing. What we have done is, we in the first few videos we had done the installation part, how to initialize thing, and in this particular video we have gone about 40 to 45 commands, or maybe about 50 commands. All these commands I'll be sharing it in the description in a Google Drive link, which will also list out all the files. I may have it already, I think. Yeah, so this is the file that I'll be sharing, and absolutely in the same format that I have done in the video. All these files, all these commands sequentially I have given. So what you can start with is all these the first few commands, all this I had already done. This basically constituted the installation part, how to install and how to go about. And then I started with all these IPFS commands, config show. So you can take a printout, or you can just have a PDF reference while you do it all. And when you do it, there will be few similarities. If you just make these files BNAB with the same content, blockchain nuts bolts, so you will get more or less absolutely the same hashes that I have derived here. But I would recommend and advise that when you do it yourself, you make your own files, you play with all these commands. And basically this tutorial or this video focused on the basic just playing around with the commands. So herewith I end this video, and I thank you very much for watching till here. And in case you have learned something, I would request you to kindly subscribe and like the video. Thank you very much.